Welcome to Team 84's group presentation on our project, Better Living. Our members are Deci, Raisa, Matt, Sandoval, and Jiang. When this project started, we went to office hours and heard that successful projects in the past first identified a target demographic, and then designed something which improves that target demographic's overall well-being. So, Matt and myself, we haven't been to the doctor in over 5 years, and we're aware that this could be bad, but between school, work, family, and other stuff, we just never really got around to it. And so we got to thinking, there's no way we're the only ones who do this. So we set our target demographic for this project to be Americans who put off health screenings beyond the recommended time frame. We did a bit of research, and we were shocked to find that 77% of Americans at least occasionally admit to putting off health screenings beyond the recommended time frame. That's more than 3 out of 4. So we knew the problem was bad, but we didn't expect it to be this bad. So 3 out of 4 Americans delay health screenings. So what's the big deal? Well, many health conditions, including deadly ones, like cancer and heart disease, they develop gradually and may not show symptoms until they reach advanced stages. And so, without screenings, these diseases can progress, leading to more severe complications, fewer treatment options, and higher healthcare costs. So, clearly, delaying your checkups can be bad. But if it's so bad, why are so many Americans still delaying? Well, there are 2 main reasons. First is that they're too busy. Other stuff, such as work and family, get in the way, and scheduling health screenings is seen more of as a chore than a necessity, even if it's just once per year. And second is that they just feel fine. And this is totally me. I don't feel sick, so I don't really think about scheduling a checkup. And in the blink of an eye, it's been over 5 years since I last saw a doctor. So what can be done about all this? Well, research shows that there's actually a very effective solution. Nagging, which is defined as persistent urging. If you take a look at this graph, 90% of young adults and 88% of middle-aged adults say that nagging is at least somewhat effective at getting them to take action regarding their health. So if you extrapolate this to the 77% of Americans who put off health screenings, that's a lot of people that you're getting to take action. And if we look into the specifics at which type of nagging are most effective, text reminders are number 1, followed by phone reminders. So we decided to leverage all this data to make a web app called Better Living, with the purpose of reducing the amount of Americans who put off their health screenings. So the idea is that users would be able to upload their data, such as their blood type, family history, as well as their age and the last time that they saw a doctor. And at 5:30 p.m. Pacific time each day, usually everyone would be off work by then, our web app would go through the list of users who have opted in for notifications. Now, if the current date exceeds a year since the user's last doctor's visit, then our web app sends a nag to the user, urging them to schedule a checkup. So originally, we intended to send a daily text notification to all users in our system who haven't seen their doctor in over a year. However, our mentor made a really good suggestion that those older than 65 might be more receptive to a phone call instead of a text message. And so that's what we did. If the user is younger than 65, they'll receive a nag in the form of a text message. And if the user is 65 or older, then they will receive an automated call instead. Now, here's Matt to start us off with the demonstration of our web app.
For the Better Living application, we deployed 4 Ubuntu servers on AWS. We implemented the separation of concern design pattern, assigning each server to handle a specific aspect of the application. This approach enabled us to work on different components concurrently. The separation of concern also enhances security by restricting user access through the interface and limiting what users can view and interact with based on permissions. The first server we deployed was the auth server, which handles user authentication and authorization with the OAuth 2 open standard and Flask endpoints. The interface server hosts the user interface built with the Flask web framework. The API server hosts the HappyFire JPA, Postgres database, and Flask endpoints. One issue we encountered with this server is HappyFire is very resource intensive. We had to rebuild the server with more resources to handle Happy. Even with this higher paid tier server, HappyFire is still slow when creating new patients or adding observations. The last server is the SMS server, which queries the user database and sends notifications to Twilio, where Twilio will make phone calls or send text messages. I will be demonstrating the authentication and authorization process in our application. In this demonstration, the applications will be running locally so we can see the transactions. This is the console output for the API, the console output for the interface, and the console output for the auth manager. We begin by entering our user credentials. The interface sends the user credentials to the auth manager. The auth manager receives the user credentials. It validates the credentials to what's in the user database. It returns the token and saves the token in the OAuth 2 database. Now, when we want to receive or when we want to view a protected route, the interface sends the token to the API. The API decodes the token. It extracts the MRN and checks to make sure the token's not expired. It sends the token to the auth manager for validation. The auth manager receives the token, checks the OAuth 2 database to check to see that's a valid token. The token is valid, and it sends back to the API that it's valid. Once the API validates the token, the information is sent to the interface, which you can see here. We use the Python package Fire client to process and format data when performing transactions with our Happy Fire server. We wrote Python functions to create patients, search observables by MRNs, and create observations with the required information, such as codes, displayed text, units, and system values. To create a new Fire patient, the first thing we do is register a new user. The user is created in the user database. Now we need to log in. Once logged in, we have to update our profile. Once we update our profile, the Fire patient will be created. So once we update the profile, what it does is it will save the information in the user database, and it will also send a request to the API to create a patient in the Fire database. As you see, it received the JSON with the information. It used Fire client to format the data. Then it sent it to Happy Fire, where Happy Fire responded with print of the patient that we just created. Once we updated the profile, we have to log out, log back in. What this does is it issues a new token with MRN encoded in it. We're going to enter an observation. We select the type. We enter a value. This is the API console. The first thing the API does is validate the token. This is the information it received from the interface. We use Fire client to format the observation in the correct Fire format. Then it is sent to the Happy Fire server for processing. Once the Fire server processes it, it returns the observation. The application redirects us to the Show Observation page, where the API once again validates the token, extracts the MRN, then uses Fire client to format the search request. The search request is then sent to Happy Fire for processing. Once processed, the Fire data is formatted with Fire client, and the JSON is sent to the interface.
We have an upload and download option in our app, So the upload will just take a CSV file and upload it to the server, and the download will be allowing the users to download whichever files they've uploaded into the system or any of records they may have. So here in the dashboard, we see the various options, and we have a upload records. So if we click on this, we are allowed to choose a file to upload. We can upload the test heart rate data, do an upload. And once it's been uploaded successfully, it will go back to the dashboard. Then we can go back to the download, to the upload download option, go to the download, and then we should see all the files that we have already uploaded. So this is a very minimal feature right now. In the future, we do want to be able to download whatever the observation data or other vital data that the users have uploaded into the system. But for now, this is what we have. Also to note, this is working in the local environment. However, when we do try it in the public server, we do encounter some issues. So for example, I want to upload patient 2 and we do encounter some server issues. However, we are able to successfully download some data from there. Yeah, so that was the upload download function. In the future, we do want to make it more versatile, where it does take in the records that were uploaded into the FHIR system, and as well as any of data that the users would want to visualize eventually.
This is a demonstration of our web app's automated SMS and call feature. We set it up so that at 5:30 p.m. Pacific time each day, our web app goes through the list of users who've opted into notifications, and then it sends them an automated text if they're younger than 65, or it sends them an automated call if they're 65 or older. Now, right now it's 10:30. We just switched it because I was busy at 5:30 today. So we should be expecting like a call any moment now. Oh, there it is. Okay, so I'm gonna take it and I'm gonna turn on the speaker so you can hear the automated message.
This is Better Living. It has been over a year since you last saw your doctor. For your well-being, please schedule an appointment with your doctor when you get the chance.
All right, so there it is. So in the web app, I registered my phone number under a user who was older than 65, so you could hear the phone call. But if I was younger than 65, then instead I would get a text message. So let me go ahead and pull up that text message here. I'm just gonna shift it away. One sec. Let's see. All right. Okay, so I pulled it up. Yeah, so if we were younger than 65, then we would get this message again. There's a bit of a glare. So here it says, "Hi there, this is Better Living. It has been over a year since you last saw your doctor. For your well-being, please schedule an appointment with your doctor when you get the chance."
Our future work involves implementing a data visualization feature which will allow users to see high-level trends of their health, such as average sleep data, blood oxygen levels, heart rates, or any information that they would like to better understand. This may also help users identify what questions to ask during their next health screening. We hope this was informative. Thank you for your time learning about our project.